we will look at some special relationship, one-to-one and recursive relationship. Let me just briefly review about this conceptual modeling one more time. So here we have three relationships, department and employee. First relationship is employment. So one department is employing many employees, and one employee is working for one department. So given this one-to-many relationship, we have to figure out what's the primary key and the foreign key, since the join condition is critical in SQL building. So one side, the primary key is department name, and the many side foreign key is among many foreign keys. The number one foreign key given here is describing the first relationship. So in this foreign key department name, we can see, given one specific employee, where this employee is working. So the affiliation of this employee is stored in many side as a foreign key. Now there is another relationship. Second relationship is manager relationship. We also talked about this in conceptual modeling. So given one department, there is one manager, and one employee can manage only one department, but depending on employee's role, if employee is not manager, this employee may not manage any department, so one side here, left side, is optional. Even one-to-one relationship, there is a foreign key and a primary key. So for this second relationship, what is the foreign key? Although here, the other side, we have department name, and here employee number as a primary key. For one-to-one relationship, there is no specific rule where you have to put the foreign key, but we were trying to minimize blank null values. So where we did put the foreign key in conceptual modeling, actually we put this employee number that's referencing this primary key of employee number on the department table. So the meaning of this employee number is manager. So who is managing each department? So if you match this employee number, you have to use the join statement like department's employee number is matched with employee's employee number. So that kind of statement may be used to find the details of each department's managers. Lastly, we have this recursive relationship. So the recursive relationship, to explain this, we talked about supervisor, and there is a supervisee. And or we sometimes use the term boss in this topic, and we will use worker. And one boss is supervising many workers, and one worker is supervised by one upper level supervisor. So it's a one-to-many relationship. But if we look at employee hierarchy, the top manager, for example here, let's say E1, kind of simplified hierarchy, E2 and E3. For E1, there is no supervisor. So given the top employee, there is no supervisor, so it's optional. And for bottom, like E3 and E2, there is no one. E3 can supervise it, so many side is also optional. And more specifically, this is a weekly relationship as shown here. But anyway, here, given one-to-many relationship, again, we have a primary key and foreign key. Physically, we use only one employee table, but conceptually, we are using employee table in two different ways, supervisor and supervisee. Many side and one side, since these are same employee table, we have employee number as a primary key. But many side, we need to put foreign key as well. That foreign key will reference in this supervisor's employee number. So can we put employee number one more time here? Actually, it's not allowed. So instead of using employee number one more time, we slightly change the column name as boss number. And this boss number is referencing employee number, but it's the same table, so we are recursively referencing this employee number. So the recursive relationship could be a little bit tricky, but if you consider one employee table both as a supervisor and a supervisee, it is just the same as a typical one-to-many relationship. Okay, to better understand the previous conceptual model, let me use a very simplified version of a test data set, like hypothetical data set. So we are considering two tables, department and the employee table. And here in department, I will just use department ID D1 and D2. There may be some names, so it's not that critical. And here we have, let's say, only 4 employee, E1, E2, E3, 4 as an employee number. So employee number is primary key, and I'm going to use E1, E2, E3, and E4. So let me use the first relationship again to make it a little bit easier. I will just use a typical one-to-many relationship here, and I will not add any details like whether it's optional or mandatory. Here for department one side, employee many side, and it's employment relationship. So based on this, we need to add the foreign key, and this foreign key is referencing the primary key of a department. Suppose E1 is working for department 1, E2 is also working for department 1, E3 is working for department 2, E4 is working for department 2. So for example, if D1 is marketing and D2 is sales department, we know that there are 2 employees in the marketing department and 2 employees in the sales department by matching this foreign key with this primary key. So that's how we use employment relationship. And later, when you make a joint statement, you may need to consider employees department and department's department code. Another relationship we consider is one-to-one relationship. This one-to-one relationship is manager relationship. So in one-to-one relationship, where we put the foreign key in department side, and suppose among these 2 employees working for D1, let's say E1 is the manager, then we put E1 here, and what's the meaning of this? The manager of department 1 is E1. Suppose in department 2, sales department, between this D3 and E4, let's say E4 is the manager. Then we put E4 here as the manager. So if you want to find any details about manager information, here suppose for the sales department, you will read the department table and you will find E4 as the manager ID. And by matching this E4 here with the employee's primary key, employee number, you can find more details here. So that's how we can retrieve manager's information using this one-to-one relationship. So again, the joint statement you may consider later is department's employee number, the meaning is a manager number, matched with employee's employee number. That would be the joint condition. Lastly, we talked about recursive relationship. So for recursive relationship, let's say we have this kind of hierarchy. E1 is the king of this company, and let's say there is E2, and let's say there is E4, and under E4, let's say there is E3, something like that. Then how can we describe this? Here we have only one employee table, but let's say we conceptually divide it into supervisor and the supervisee. Again, we will not have actual tables called the supervisor and supervisee, but for better understanding, Let's say there are two separate tables, but it's gonna be same employee table. So I will list up 1, 2, 3, 4, 1, 2, 3, 4. So let me just put the same information: E1, E2, E3, E4. All those employees could be supervisor, and who would be supervised? The same employees. So E1, E2, E3, E4. But if you look at this hierarchy, you can see there is a relationship. One level upper is called supervisor. So this supervisor is supervising many supervisees. But if you pick one supervisor like E3, there is only one supervisor. Even E2, only one supervisor. So one supervisor has many supervisees like here. For one supervisee, when you pick, there is only one parent, one supervisor. So it's one-to-many relationship. So how can we describe this relationship? Many side here in supervising, we need to create a foreign key that is referencing this one side primary key. So we have to add this supervisor information. So given E1, who is a supervisor? There is no one on top of this E1. So actually there is no one for this foreign key. For E2, who is a supervisor? Here E2, E1 is a supervisor. So we have to put E1. For E3, who is a supervisor? For E3, actually E4 is a supervisor. So E4. For E4, we have the same supervisor as E2. E1 is a supervisor, so E1. So this column, if you name it, it's gonna be employee number as well. But here we have also employee number as the primary key. So you need to change the column name. So we use supervisor number as the column name for this foreign key. So although conceptually you can understand this in two separate entities or tables, but physically they are same, so we don't need to use two tables, but we are going to use the same employee table. But we need to add one more column, and as shown here as a supervisee, we have none for E1, but E1 as a supervisor, E4 as a supervisor, and E1 again as a supervisor. So using this department and the employee table, here inside we have a one-to-many relationship. One's employee as a supervisor and the other as a supervisee. We can keep all the information here. So that is kind of an example that follows previous conceptual model. And we will look at now real data with some sample questions. So first of all, in your note, you have this SQL statements to create department and employee tables. So please run this. First, you will drop the table if it exists, and it will recreate department table and employee table. Also, the insert statements is given, so you can insert data for department and employee. Just one note here is when you insert the first employee, since we do not have here the last column boss number for Alice, the top manager, so here we have to list the column names that we have. Only one value here, the last one is missing, so we need to list up all those column names for the first employee. So let's just run everything together in the databases. You can get these two tables, department, employee. So let's look at department. So we have accounting, management, marketing, personal, purchasing department, and there is employee number. These are both numbers. And if you click employee, we have 8 employees, and this department name means where they work. And the boss number means the recursive hierarchy, so who is the one level upper boss. So given this data, now let's start with one-to-one relationship. Okay, the question is list the salary of each department's boss. List the salary of each department's boss. So let's go back to database. And first, let's start with the department. And here in each department, we have boss number, not boss number, manager number here, employee number. So we need to match this employee number with employee tables employee number. Then we are making join statements for this one-to-one relationship. Okay, so let's first make a select statements here. Let's list everything, and we will modify this column list later. From, we have two tables. We are using employee and the department. And the join condition for one-to-one relationship is, again, imagine in the department we have employee number. So department employee number. The meaning is the manager's employee number for each department. That should be matched with employee tables employee number. So we made a join condition based on one-to-one relationship. So let's run this first. Okay, so here, after we executed, the first columns is from employee table, and the following column is from department table. Please note that from employee table we have department name, and here department name following is the primary key of the department table. The meaning is a little bit different. The department name here shown is the list of department, and we are looking at the managers. But the department from here, the first one is from employee table, and this department name means where each employee works. Right now in the current data, actually both department name, they are just the same. But you have to consider it a little bit differently, because this department where employee works could be different from this department name. For example, let's say in accounting department, employee number 5 is Todd. So Todd is the manager. So it makes sense Todd is also currently working for accounting department. But suppose, let's say Todd is working for marketing department, but temporarily Todd is assigned as the accounting department managers. Then what's gonna happen? This department name is still, we are describing accounting department, but when we look at the manager 5 Todd, if Todd is working for marketing department, which column? This column, department name column in employee table, would be marketing. The meaning where each employee is working right now, it is described in this department name of the employee table. But it could be different from managing department. Okay, so why I am distinguishing this? Because if you specify the column name, let's say the first is the employee first name, and second one is, let's say, the department name, and the third one is, let's say, employee's salary. Now, employee first name and employee salary is from employee table, so you don't need any qualifier. But department name, it's shown in both employee table and the department. So in this case, right now in our current data, both employee tables department name and the department tables department name, even without join condition, they are all matched, as I have showed you. But in this column list, we are supposed to show the managing department, the employee is managing. In that case, we have to qualify this, strictly speaking, with department table as a qualifier. Because if you put just the employee here, that means current employee is working department. So it's a little bit different from the managing department. It's about recursive relationship. So given the recursive relationship with the employee hierarchy, we want to find the salary of Nancy's boss. So again, if we go back to data, so let's talk about how to use the data. Okay, so let's look at our employee table. And first, we will look at this employee as just a worker. And we will find Nancy based on employee's first name. So employee Nancy's employee number is 6. And we know the salary is 22,000. And but at the same time, we want to know about both numbers. So it's 5. So using 5, we will match from employee table again. Now we are reading this employee name table as a boss, and the 5 is third, and we found that salary is 38,000. So we are using employee table 2 times, one as a worker, the other as a boss. And always remember, worker's boss number matched with boss's employee number. So let's develop SQL here. Okay, so here we want to select from employee table. We are showing employee's first name, Nancy first. And then we want to know Nancy's salary, so employee salary. And then we need to show both information as well. So employee first name again, but this time this is describing both. So it's third. And the third salary as well, so employee salary. So it looks pretty weird, right? Because employee first name 2 times, but the meaning is different. Employee salary 2 times, but one for worker, one for boss. So we are going to add some qualifier later. But here first, let's think about what tables we need to use. We are using employee table, just one table. However, we use employee table 2 times. So let's say there are 2 employee physical tables we are using. And then where we need to describe the join condition first. What's going to be the join condition? Again, workers boss number matched with boss's employee number. So now this time we need to distinguish these 2 employee tables. One as a worker, the other one as a boss. So what would be a kind of good trick? We can use alias. So I will call the first employee from now on, let's say worker, WRK. And the second one, let's just call boss. So now, although physically there is one table, consider there are 2 tables, worker, work, WRK, and boss. Then, how can we describe join conditions? The many side, workers, what's the column name? Employee, not employee, actually boss number. So boss number matched with one side. One side we will call boss. And then the column name is employee number. So by using this alias work and boss, now we can just consider these 2 tables linked by one-to-many relationship. So many side foreign key is matched with one side primary key. And if you run this first, you will get the result. But before we run it, it's now employee first name is ambiguous. The reason is both work and boss, they have employee first name. So first one, let's say it's workers. So worker, WRK alias is used as a qualifier. And the employee salary is also about worker. And followed by boss information. Boss is name and the boss is salary. We did not specify this is for Nancy, but let's try to run this statements first. Okay, let's execute it. So now you can see the nice list of workers, employee name, and the matching boss. So Naz, boss is Alice, Andrew's boss is Ned, Claire's boss is Ned, like this. So particularly what we are looking for here, the Nancy worker's first name, and the Todd, her boss, and now we have salary 22,000. Boss's salary 38,000. So we need to specify this row. So one more condition we need to add here is after this or before, we need to add here whose first name? Workers. Okay, so let's add one more condition here. It is employee first name that equals to specific name is Nancy. So here Nancy, the name is Nancy here, and then let's connect this, and so we have two conditions. But note that this employee first name, it is what ambiguous. So you have to specify, is it worker or boss? Workers, employee first name is Nancy. So the complete statement is given here. Let's test it. So we get the result, just one row for Nancy's salary and Todd's salary. Okay, so in the previous example, using a alias for the employee table, we nicely describe the one-to-many recursive relationship, and we could make a join statements. Since we are talking about alias, let me give you one more example how convenient it is to use alias for the tables. So as an example here, list the name of everyone who manages a department. This is a pretty similar example we have run already here about manager information. So let me copy and paste here, and I will slightly modify. So using alias means even without recursive relationship, can we call this employee as just E, and can we call just department as T? Then you can make a join condition simply department with D as a qualifier, employee, you can just E as a qualifier. And even employee first name and department name, let's say employee salary, we are not showing, but department, we need to qualify, then you can just put D. That's very simple. So here is the example how we can use alias. If your SQL statement is very long and complex, using alias you can make it a little bit more concise. So you can get the result, employee and its department, managing department shown here. Now as the last example, let's look at one more recursive relationship. A very interesting question. Find the names of employees who earn more than their boss. This boss may not be very happy, right? Because their workers are earning more. So let's find it. So here in employee, first we need to find the relationship. So worker and the boss, and we have to match employee salary. So I may start with what we have done before. So to solve this question, let's look at the previous example here, employee name, salary, name, salary. So let me copy this statement first about Nancy. So it's not about Nancy, but I want to list up one more time, workers' salary and their boss's salary. So here, let's run this first. So here what we got is workers' salary is given here, and the boss's salary on the right side. So in general, you can see boss's salary is higher, but if you scroll down here, when you can get the row or information where boss's salary is lower than worker's salary, here we have Sarah's salary is 56, but for this boss's salary, Briar's salary is less 43,000. So in your SQL statements, now condition is after this join, and what should be the conditions? Yes, workers salary, employee salary must be greater than boss's employee salary. So this is the condition you need to add. If you execute it, so let's see here. Yes, you will get this information. Sarah's salary is greater than Briar. So if you just want to show the first column, employee first name Sarah, you can go back to your SQL and then Other information you can just delete, and you can just show with qualifier WRK worker's employee first name. Then it will show just the Sarah at the name of the worker who earn more than her boss.